In this edition of the Embedded Insiders podcast, Brandon and Rich continue their journey into the world of open source, this time by focusing on Z-Wave that was recently donated to the community by Silicon Labs, who acquired the network technology from Sigma Designs. Later, the Embedded Insiders are joined by Laurens Slats from the Things Industries, who continues a discussion of open source networking technologies by outlining the state of LoRa and LoRaWAN. Finally, John Labrosse is back with Things That Annoy, a veteran software engineer, where he explains why the 80-column limit is stupid.
Good afternoon and welcome to the Embedded Insiders. I am Rich Nass, Executive Vice President of Open Systems Media and leader of the Embedded Computing Design franchise. Here with Brandon Lewis, who's slightly under the weather. Brandon?
Hello.
All right, so the topic for today is one that we have talked about a lot, open source. And I think it's one of your favorite subjects, right?
Definitely. It's taking over the world. We talked about RISC-V and, how that open standard is leading to a lot of open source silicon. And it's a nice little segue that today we're talking about a different part of the semiconductor industry that's being open sourced, Z-Wave.
It's actually funny, though, because I've always struggled with open source hardware and never really understood where it fit. We had RISC-V. Okay, well, there's one example. Now we actually have a second example. So, maybe open source hardware will be just as significant as software down the road. So what I'm referring to is that Silicon Labs is opening up the Z-Wave specification so anybody can produce a Z-Wave microprocessor. In the past, it was free to design with the spec, but the only one who was producing processors was Silicon Labs through their acquisition of Sigma Designs. What do you think, before I give my opinion? Do you think that's good, bad, indifferent?
So when you look at that sort of short-range wireless landscape and those technologies that are being used particularly in home automation or maybe some commercial automation, Z-Wave is, I guess you could call it one of the big three, but the gap is pretty significant. So obviously the other two big contenders there are Bluetooth and Zigbee, and then to some extent Wi-Fi. But we'll just stay with these shorter range, lower power specs for now. So opening up Z-Wave is an interesting move. You're really just sort of trying to salt the mine. If you have open designs and allow a lot more people to put Z-Wave products out in the market, growing the pie for that technology, and hopefully Silicon Labs, given their history with the tech, will be where customers default when they're looking to commercialize.
Is this admission by Silicon Labs that it wasn't what they thought it was, and it's just not as popular as they thought?
I don't think that's necessarily the case. You see a lot of companies through technology and then spit them out in one way or another. It's interesting. Scilabs acquired Micrium, and Micrium, their microCOS, is open source. It's sort of the same strategy. If a lot of people are familiar with the technology, they get their hands on it, they start designing with it, the more the merrier, right? Because eventually, if you're serious, you're going to need to go to market, and Silicon Labs has a lot of experience now in Z-Wave, microCOS, etc.
I was pretty much playing devil advocate with you. I also think it's a good idea, and I hate using these cliches, but the rising tide raises all boats kind of thing. If they can get the Z-Wave market to grow in a significant way, they'll still be the dominant player there. So I think it's a good idea, and I would guess that's the strategy behind it.
Yeah, I mean the big problem that they're going to face is what the one I mentioned earlier. They're up against these mammoth technologies like Bluetooth, and just the economies of scale, the number of people who are familiar with Bluetooth versus Z-Wave means that they've got a lot of ground to make up. But yeah, look at Linux. I mean, it's out there. All of a sudden, we've got hundreds of thousands of people working on Linux, and then there are the Red Hats of the world, the Wind Rivers of the world, who sit there at the end. Okay, so you built something cool, but you need to harden it for the market, and here we are to help.
Now, the Embedded Insiders are joined by Laurens Slats from the Things Industries.
To today we really want to jump into some topics we've discussed in previous podcasts about LoRa and LoRaWAN technology. But first, for those in the audience who aren't aware, can you tell us a little bit about Things Industries and what your role is in this ecosystem?
So the Things Industries is a LoRaWAN service provider. So we have a lot of tools for companies to build their LoRaWAN network. So the Things Industries, it's the creator of the Things Network, and the Things Network is one of the biggest LoRaWAN networks worldwide. It's an open, community-driven LoRaWAN network that now contains about 100,000 IoT professionals that together run about 10,000 gateways all across the world. I believe now on a daily basis we route about 15 to 20 million packets back and forth. Wow. So if you really compare it to big telcos, then that's maybe not a very big number, but I think it doubles more than every year if you look at how much we route at the Things Network. We try to be interoperable with any LoRaWAN network and any LoRaWAN provider out there. So that means that all the different LoRaWAN network servers, we working together on enabling roaming and peering between these networks. And there's something very interesting, which is more about kind of fusing different radio technologies. So at the one hand, you use LoRaWAN for the long-range communication, but you can combine it with Wi-Fi or Bluetooth or different technologies. Which makes it, for example, very interesting with asset tracking. So use, for example, the location features of Bluetooth beaconing or Wi-Fi scanning, and then translate these kind of sensor readings over LoRaWAN.
One of the things that I think is important to note is that there are really two elements of LoRa technology. First, there's LoRa, that's the modulation technology in the PHY, and that's licensed by Semtech. And then separately, there's LoRaWAN, and a lot of that is open. Can you explain what elements of the technology stack are really open and available to the community and being driven by the ecosystem like the Things Network?
So LoRa stands for long range, and that's a modulation technology to modulate basically binary data, which your sensor data consists of. And it can modulate this binary data to a wave format that can be sent via an antenna on a IoT device. So this kind of technology, that's called LoRa, and that's invented by a company that's called Cycleo. And this company was acquired in 2012 by Semtech, and Semtech is now basically the holder of that IP. And around this modulation technology, there is a standard, and that's called LoRaWAN. And LoRaWAN is an open standard, so anyone can use it. There's also an open alliance involved. It's called the LoRa Alliance. And at this moment, there are, I think, over 500 companies that are now part of this LoRa Alliance that are really trying to push this technology, to bring it to market, and to further develop the technology as a whole. How I see it at this point is that Semtech actually has been thus far the main driver of this whole technology. And they are also the founder of this, one of the founders of this LoRa Alliance. And so the good thing about having Semtech as the owner of the IP is that that they are really there to build this whole market. So they are open to collaborate with anyone. So you don't exclude any partner anywhere, because they really want to drive this technology globally. But yeah, of course, there's a little bit of risk involved by having this IP only in the hands of one company. And that's, I believe, also why they license it now to different companies, to different chip manufacturers, including Microchip and ST. And yeah, it's a big question how the future involved, and whether they really keep this IP or at some point decide to open it up. It's also very new technology, so it only exists for 4 years or so. Mm-hmm. And as with any new technology, there've been a lot of challenges at the beginning. And I'm actually quite confident that at this stage the whole technology really matured and is ready to be fully implemented at scale. And you can, for example, see that at the new specifications that came out. provided by the LoRa Alliance. Like a few developments have been released that even further increase the security of IoT devices. But you also see at hardware vendors that now almost all of them already released their second generation of these LoRaWAN chips, all making it smaller, cheaper, more sensitive, so it can even pick up more IoT packets at longer range. So in that sense, you really see the market maturing.
What's the things network and things industry is working on now? What's next for you?
What's next? So we are now organizing the third edition of the Things Conference, which is a global event targeting about 2,000 LoRaWAN professionals. It will take place in Amsterdam on January 30 and 31st, and the idea is to bring the whole LoRaWAN ecosystem together, to have all the relevant partners and companies be there and showcase their latest developments, innovations, and I think the good thing is that the event is really hands-on. So anything that the partner presents, you can directly experience it during workshops and really experience the technology and the hardware at the event itself.
Now it's time for Things That Annoy a Veteran Software Engineer with John Labrosse.
The biggest thing to me that irritates me is the 80-column limit. I mean, and that's very religious topic, but a lot of programmers like to limit their code to 80 columns, and I find that completely ridiculous because, names of variables are much longer, so now they have a tendency to wrap around the next line. And with the 80-column limit, a lot of programmers are actually putting code and comment in relief. So you got comment between lines 1 and 80, and then code that follows, and then comments and code and so on. My preferred way is to not limit to 80 columns and actually use, hopefully, modern monitors that we have available today. I actually have a 4K monitor. I could actually put 3 or 4 pages worth of code next to each other, and I'm not limited to 80 columns. Of course, I need to wear glasses with that, but at least I get to see the whole a bigger picture. Because with code, you're still looking at a small window of the whole project when you're using a code editor. I believe that people got used to 80 by 25, 80 columns by 25 line monitors, and wrote a whole bunch of code around that. And then when the bigger monitor came around, then hey, we're used to doing it like that. But just imagine if you have to create code tables, for example, a whole bunch of columns worth of initialized data. Then what happens is you're going to have to wrap around the 80 columns. Whereas if you're putting more than 80 columns, then you could actually put vertically a column of values. So if you're putting temperatures in one column, pressures in another column, altitude in another column, it's a lot easier to see than if you're putting those elements on separate lines because you're limited to that 80 column limit. As new programmers come along, they see the old code from the company, and they basically say, oh, well, that's how they are doing it, so we'll do the same thing, and it propagates, unfortunately. You need to have somebody that actually sets these rules and say, look, you have to use the code editor and what makes sense. And I'm a lot anal retentive, so I like to line things up. I like to put spaces between stuff so that actually it's more readable. But some programmers, just don't do that.
Thanks for listening to this edition of the Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.